makes you take surveys.
And we are covering parabolas. Okay? Parabola. Parabola. I try to be a nice guy because sometimes people forget about that. And they forget to throw away because it's so short. So I try to help you out. Okay. So, we graphed a parabola yesterday, didn't we? What parabola did we graph? It's the basic y equals x squared. Remember, what did I tell you guys to do? If you don't know what the graph looks like, what do? Plot points, correct? What points did I ask you to pick last time? I found 5. Thank you, Corey. -2, -1, 0, 1, and 2. And when I plug them in, I get -2 squared, which is 4, -1 plus 1, plus 0 over 1 and 4. Caden, you doing all right, brother? Testing today? What day did we say we're going to test? Testing? You did. Okay. And then we graph this guy. It looks like this. Everybody remember the U shape we talked about? Okay. We have two parts to this graph. We have an increasing part and a decreasing part, correct? You guys see where the graph is increasing, where it is decreasing. Okay, decreasing means as I move left to right, what's happening to my y value? They're going down. They're lower than the one previously, right? Does that make sense to everyone? So this part is decreasing. Do you agree with that? What does increasing mean? As you move right to left, your y value would be larger than the previous one. That part is increasing, isn't it? Okay, so has anybody thought about how many of you guys have done domain and range before? Last year you should have learned it, right, hopefully. How many of you guys saw integral notation where it looks like this? So like my domain was negative infinity to infinity with a parenthesis. How many of you guys use that? Raise your hand if you got it so I kind of get an idea. How many of you guys just said all real numbers? Something like that. Anybody do that? Yeah, you didn't really see this at all? Thought it was well done? Okay, today we're going to do what we call interval notation. The negative infinity to infinity type of thing is interval notation. Okay? But today I'd like you to tell me what is the interval and where it's decreasing and where it increases. Okay? So, with that being said, all right, here we go. So where is it decreasing at? That's a bad color. Let's get it. Where is our graph decreasing at? We're looking at the x values. What x values are my graph decreasing? By the way, this graph goes on forever upwards, right? So therefore that means it's also going to the left forever, correct? Does that make sense to everyone? Yes or no? Okay. So where is this graph decreasing? Where does it start decreasing? Starts at negative infinity. Let me explain this. Maybe you guys can get it after I show you maybe, okay? Over here at negative infinity, our graph is all the way up here. I can't touch it. You get the idea. It's really high, right? But as I start moving this way, it's getting lower and lower and lower and lower and lower. Correct? So from negative infinity to what does it decrease? 0, right? At 0, it stops decreasing. Does everybody see that? Yes, no? How many of you guys are wondering, Mr. Roberts, this is positive. Why are you using a negative? Anybody using that question? I usually get that question quite a bit. Okay? You're thinking of the y values, Haley, then. Okay? Now notice I'm asking which x values give me y values that are decreasing. If I plug in any x value between negative infinity to 0, if I pick a number to the right or larger than it, the y value will be smaller. Does that make sense what I'm saying? So therefore, this is the interval on where the graph is decreasing. Okay? For those that did interval notation, what does a parenthesis mean? Do you remember? What does it mean, Caleb? A bracket, good. Does anyone remember what a bracket meant? I'll give you a kind of an analogy of what they are. A parenthesis and a bracket, that's what you're going to have to use. A parenthesis is kind of like a greater than or a less than. It means it doesn't use that number. Right? It goes up to that number, but not to that number. Going okay? You need to go to the bathroom right now? Well, okay. You feeling lightheaded? You need a volunteer to walk to the bathroom. Do you want to go to the office? What do you want to do? So can I touch 0? No, I can't because once again you're stopped. Not increasing or decreasing at 0. That's the low point. If you think about a mountain, climb to the top of the mountain, and you're to the peak or the very top. Are you increasing anymore? Are you decreasing anymore? You're at the top. As soon as you start walking down, that begins your adventure of decreasing, right? Okay, does that make sense how this comes about? Haley? Okay, so once again, think about it. As we are going through, you're decreasing from here to there. At 0, am I going down? That's the lowest that graph ever is, right? Am I decreasing if I'm at the lowest point? So right up until 0, for the x value, I was decreasing, right? But what's the largest, what's the small, okay, how do I want to say this? What's the largest number less than 0? What's the largest number? Let's see, that's the lowest number, right? Because negative infinity is technically very, very small number, right? Negative 2 is less than negative 1. What is the largest number less than 0? Negative 1 isn't 1 either, right? There's another number, negative a half is larger than negative 1, right? What's the largest number less than 0? Negative 0.0000000000000001? Is that it? No, there's another number smaller than that, right? I mean larger than that. You get what I'm trying to say? So can I use a bracket on this? No, because there's not a number that's less than 0 that's enough that I can actually physically use. Let me get on to another problem. I think you'll see it a little bit better. Okay? Usually this one, because it's 0, people struggle with just a little bit. Can I give you another shot and then see if you can round into it? Yes, sir. What are they used for? It's for interval notation. So remember, if you're using a parenthesis, it's kind of like a greater than or a less than. If it's a bracket, it's like a greater than or equal to or a less than or equal to, meaning you would include that number. Okay, where is this graph increasing at? Where does it start increasing? Does it include 0? If I'm at the bottom of the stairs and I'm looking to go up, am I increasing at the bottom of the stairs? I'm not. So it would be 0 to infinity, because from here over, my graph is going up. Okay? Maybe right now you guys are 50-50 right now. Would you agree on the increasing, decreasing? Hopefully after this example, which is a little bit different, okay, you will feel better. Okay, here's a graph. I'm not actually making you study this graph right now, but it will help you, I think, in the increasing, decreasing part. Okay? Let's assume this point right here is negative 1, 3. This point right here, let's say, is 2, 1, negative 1. Does everybody see that? How many parts are increasing of this graph? We have 2 increasing parts, don't we? Can we see that? This part right here is increasing, and as we go left to right, our y values are going up, correct? Where else is it increasing? From this point that way, correct? Everybody see that? Yes, no? intervals. What intervals or what x values give me an increasing value? Okay, so where am I starting? Even though he's going down, which way am I going? Where does it start? It's that way. Negative infinity. Does everybody understand? Negative infinity to what? Where do we start? Stop increasing. Where do we stop? Do I keep increasing here? Yeah? How about here? Sure, where do I stop? Right there. At the high point, right? Thank you. Correct? Does that make sense? This is the stopping point. I'm not increasing anymore, so what's the stopping point? -1. I'm increasing from negative infinity to -1. It's the x values. Now some of you guys are like, Mr. Roberts, it says a 3. I'm increasing up to 3. No! You're thinking of, those are, oh, I had a little slobber there. A little crazy bad. Sorry. Anyway, from negative infinity to -1, our x values are going up no matter what, but our y values are also going up as well, correct? Okay, where else does this graph increase? Where do we start increasing at? 2 to, not 2 to, but 2 to where? 2 to infinity. If you have more than one, you need to put a union sign. Not a U, a union. Okay, it means or. That's what it means. Okay, like I said, today on your homework, you're not going to have those because you're not doing these styles of graphs, but I think it just allows people to see the increasing intervals a little bit better. Does that make sense to everyone? Where is this graph decreasing at? Where do we start decreasing? -1 to what? To 2. Do I include those? At those points, am I decreasing at -1? I'm at the top of the stairs. Am I decreasing? Nope. But as soon as I put my leg down, then I start, correct? When I get to the floor, am I decreasing? No. So it's right up until I put my foot down on the ground, correct? Does that make sense? So hence -1 to 2, any x value in between there, if I plugged it in, my y values would start going lower and lower. On a 1 to 2, how do you guys feel? Meaning a 5 means you're awesome on this. 1 means you suck at it horribly. I need to see. Kind of give me an idea, because this is about half your homework. Okay, so we want one more, or do we feel comfy? Okay, so I'm going to do a parabola. Okay? Because that's mostly what you're going to do today, is parabolas. Okay? So, not all parabolas are at x equals 0. It might look like this. 2, 3. Everybody see that parabola? Notice we only have one increasing part and one decreasing part on a parabola, right? Everybody see that? Okay. Where would we be increasing? -infinity to what? Who said? I heard it. To 2, not 2, 3. Just the x value. So this is 2, 3, right? Does that make sense? So the x value is, I'm increasing from negative, like I'm thinking here. Am I increasing still? My x's, my y's, excuse me, yeah, all the way up until here. At this point, all this stuff was going up, correct? Okay, so -infinity to 2, I was increasing. Where am I decreasing? 2 to infinity, right, Caden? Caden? Cade, son of a monkey. I apologize. Decreasing from here, notice from here on that way, I would be going down, right? The x values, these are the x values. You know, you're visualizing the y's going down, but you're asking what x values are giving me the y's going down. Okay? That's the hard part. You're visualizing the y's, but, right, you're saying what x values are making this do this. Okay? Yeah. Did you do domain and range last year? Okay, so let me help you on domain and range. Okay, domain, if you'll remember, is the possible x values used. I don't think that's on your homework. today, but if it was, what values can I use in this graph? I can use anything from negative infinity to infinity, right? Can I touch those guys? No. Make sense on that? Okay, range. Remember what range meant? It's the possible y values. What y values am I using? Well, I go from negative infinity up to, stop here, 3, right? Did I use 3? Is 3 part of my graph? That was this graph. So on the intervals that we're talking about increasing and decreasing, it's not right now. Like, there's a graph that we study in pre-calc that kind of goes like this, has a low point, rises, and it comes over like that. That's a constant. Okay, so notice I have a decreasing part, an increasing, and then a constant. Does that make sense? So let's say this point's right here, 2, 2. This point right here is 4, 4. Just pretending. Okay, so I'd be decreasing from negative infinity to 2. Does that make sense? I'm increasing between 2 to 4. I am constant from 4 to infinity, but I am including 4. Because at 4, I'm at that value that stays constant the rest of the time. Does that make sense? If, like, for example, okay, go to the airport, okay? You're on the escalator, right? Let's say we got on the escalator, we were going down. We got to the bottom, we went back up. So at that point, that's why they don't include that. Does that make sense? But let's say at the end of the time when I started increasing, I get on that like excavator thing, or you get what I'm talking about, the walkway that moves. So as soon as I get to the top, I'm on that walkway that moves and it keeps me constant, right? So that's why I would include that. Does that make sense where you would use those? You cannot decrease at a constant point. Seriously, we need to do a field trip, let's go to the stairs, and I can show you. But if you really think about it, as you're walking down the stairs, up until you hit the ground, you are decreasing. But as soon as you hit the ground, are you decreasing anymore? You're stable, right? So if you think about it, as I'm walking down, just imagine me walking down, and then I'm there. As soon as I put both feet there, I am no longer decreasing. I'm just here. So the time frame that it took me to go down to that point is decreasing. Does that make sense? I know it's a little weird, but you just got to think about it. When you're at the ground, you're not decreasing or increasing anymore, right? So if you had 2 stairs that go like this, and there was just like a foot in between it, right? So you have your stairwell coming down, you have your little itty-bitty area to put your feet, and then you climb back up. At this point down here, are you decreasing or increasing? But up until you touch that, you are decreasing. But like I said, what's the largest number smaller than that? You can't really find that, so you say up until. So that's why it's a parenthesis. We feel like a 5 now. We feel better? Okay, please make sure, guys, I'm trying to help you do the best you can, because that's about a half of your homework today, is doing increasing and decreasing intervals. The other half is graphing, okay? Not all graphs that are parabola are as nice and easy as y equals x squared, such as this guy. He's not as easy as that way. Like I told you, I could pick some random points to get a rough graph. But if I pick randomly, you might have to pick more than just the 5. You might have to pick maybe 6 to 7 to 10 to 100 to get a good idea of what the graph is. Does that make sense? Yes, no? I know it's hot. I know you're tired. Please stay with me, though. Okay. So, if you'll notice, on the very first graph I did, it had a low point. What do we call that low point? A minimum, right? It has a minimum value. It's the lowest that graph ever goes. It has a minimum point, right? This graph right here, what does it have? It has a high point, which we call a maximum. Okay? So a parabola is either going to have a minimum or a high point, which is a maximum. Are we okay with that? But the key thing is we want to find that vertex, because either way, that helps us find the increasing and decreasing intervals. Does make sense what I'm saying? Yes, no, maybe so. Because as soon as I get to that high point or that low point, that tells me where I'm increasing and decreasing. Right? Okay, so I'm going to show you how to find the vertex. Notice this is the general form. It's called standard form of a quadratic trinomial. Ax squared plus bx plus c. Right sideways? Pretty legit. Sorry. You do too? Oh. Standard form. Water. Thank you. I know that one. Okay, so who's my a value here? In my equation, who's my a? A would be 1. Because what's the number in front of x squared? 1, right? Who's my b value? Who's my c value? Just to let you know, everybody okay with that? Okay, how you find your vertex is what we call the axis of symmetry. If you go back here, a parabola is symmetrical, right? I know my graph's not the perfect, but it's symmetrical. What does the word symmetrical mean? Is if I find it somewhere to fold it, it folds right on top of each other, correct? Does that make sense? My graph's not perfect, but you get the idea. Look right here. It folds at 0, and notice I have the same y values, correct? See what I'm saying? And that's the reason, because a parabola is symmetrical. Okay, this axis of symmetry is the x value of your vertex. And how we find the x value of your vertex by doing the axis of symmetry is negative b over 2a. This is the x value of your vertex, which is called the axis of symmetry. Okay? Negative b over 2a will always tell us the x value of our vertex. And if I have an x, what can I always find if I have an equation? I can find the y, can't I? Does that make sense to everyone? Yes, no? Okay, here we go. What is our a value? 1. Our b value is 4. So I go negative 4 over 2 times 1. You see how I just plugged that right in? Is this little thing important to know? It is. Okay? If that becomes negative 4 over 2, which our x value of our vertex is 2. Negative 2. Everybody understand where I got that? If I have an x, how do I find the y? Plug it in, right? So I have negative 2 squared plus 4 times negative 2 plus 3. Negative 2 squared is 4. 4 times negative 2 is 8. Negative 8, right? Plus 3. So that's negative 4 plus 3, which is negative 1. Holy sauna. Hi. Haley. Plug it in, and that'll get you a y value, right? So now, on my graph, here's negative 2, negative 1. There's my vertex right there. Now, do I know if that's a high, like this, a max point, or a low point? Do I know that yet? But I know it's the vertex. Okay? Meaning it's either going to be the low point or the high point. You good with that? Ma'am? Why did it come out positive 4? Because once again, anytime I plug it into a value, so like earlier it said negative x squared. Okay? This was earlier that you struggled with. So how did I plug values in? I'd go negative, parenthesis, negative 2 squared. Plug it in with parentheses. So that says negative 2 squared, which is 4. But then there's the negative outside would make it negative 4. So on this one, Haley, if I did negative 2 squared, that does become a positive 4 because I don't have a negative outside. Did you see the difference between the two? Okay. Everybody understand how I got that vertex? Do you guys know what a y-intercept is? Anybody give me a definition of a y-intercept? Where we cross the y-axis, right? Does everybody understand that? Does anybody know the x value of the y-axis? I mean, that's on the y-axis at all times? X is always going to be 0 every time. Because anytime I'm here, look at my finger. What is my x value always on? It's always on 0, isn't it? Does that make sense? We got another one to do, guys, so we got to hustle through this just so you can make sure. Yes, ma'am? Yep, I will scroll back it up. So therefore, I'm going to plug that 0 up into the original equation, right? What's 0 squared? 4 times 0. You guys see how this will always cancel out to be 0 when you plug 0 into this guy? So this C value, guess what C value always is? It's not always 3. In this case, C is 3, but the C value is always your y-intercept. Now I want to write that down. C is always your y-intercept. So 0, 3. Now I'm going to plot that point. 1, 2, 3. Okay, once again, what does symmetry mean? Yes, ma'am. I just chose any. When I think of the word y-intercept, I automatically know x is 0. I plugged it into the equation. If you have an x, how do you get a y, Haley? Plug it in, right? I plugged it into the original. Do you see your original x squared plus 4x plus 3? So I just plugged that in. 0, 4 times 0 is 0. 0 plus 0 plus 3. You got me? Symmetry. Okay, look at my arms. I know I'm not perfect here, okay, but bear with me here. Roughly, is my elbow the same distance away from my middle of my body right now? Are they about the same distance? Are they roughly the same height as well? We're doing a rough thing here. They're about the same height. Because they're the same distance, they're the same height because it is symmetrical, right? Does that make sense? If you are symmetrical, that means the distance away from your halfway point are going to be the same. So therefore, how many units is my y-intercept away from my vertex? How far is that? 2 units, right? So if I go 2 units this way, guess what I know? It's 3. Because it's symmetry. If they're equidistant away from the vertex, they'll have the same y value. That should make sense, doesn't it? Because it wouldn't be symmetric unless they folded right on top of each other. Right? Okay. And there's my graph. So what do we need to find? On to graph a parabola. You need to find your vertex. How do we do that vertex? Negative b over 2a. Okay? After you get that, you get your y-intercept. You plot that point. And then you use symmetry to find the other one. I'll show you. If you guys don't believe me, negative 4 is going to get 3. I'll show you. Negative 4 squared plus 4 times negative 4 plus 3, right? Wasn't that what it was? What's negative 4 squared? 16. 4 times negative 4? Negative 16. That's a 0 plus a 3, which is a 3. But I use symmetry. I didn't have to go back and do that because I know that they are symmetrical. Everybody with me on that? Okay, I'm going to kind of go fast on this because we have 6 minutes. You okay? Okay. I'm going to kind of do one with a fraction really quick. What's our first goal to do? I'm going to ask you to graph this. By the way, on that last graph, could then I ask you increasing and decreasing values? I could. Does that make sense? Okay. What is the value to find the x value of our vertex? What's the equation? Remember, it would be negative b over 2a. Is everybody okay with that? Can we change this to a negative 8 instead? Let's change that to a negative 8 really quick. Just because I want to show you what to do when it's already negative and you have a negative b. So what does negative 8 do? It makes it a positive 8. Is everybody okay with that? Yes, no? Plug in 2 times, what's the a value? Negative a half. How do we multiply fractions? Straight across. What's 2 times negative 1/2? It becomes, that's a pretty simple one. What's half of 2? 1. So it's negative 1, right? So that's negative 8. Does everybody understand how I got negative 8 as the x value of my vertex? If I have an x, I'm trying to pound this in. You have an x, what can you find? Find the y, correct? By plugging it in. Okay, here we go. I'm going to quickly do this. If you needed to use a machine, please do so. 8 squared, negative 8 squared. 64. 64 cut in negative a half is negative 32. Does that make sense where I got that value from? Negative 8 times negative 8 is 64. Everybody see where I got that from?
How do you know x is 8?
This right here tells me this is the x value of my vertex. That equation tells me the x value of my vertex.
So I think it's hard for me because I don't know what's true.
Yeah, I can help you a little bit later if that's okay.
Yeah.
Let me get through this. Does everybody understand this gives us our x value of our vertex? If not, I'll help you with it. Okay. Negative 8. Plug it in. I'm here so far plus the 1. That becomes 32 plus 1, which is 33. Does everybody see where I have that? That's my vertex. Can somebody already tell me what my y-intercept is without doing any math? You already see it. I can see it right now. My y-intercept is 0, what? 1, because that is my c value. My c value is always my y-intercept. And then it makes sense. If it doesn't, plug the 0 in. What's 0 squared? 0. 0 times negative a half. 0. 0 times negative 8. 0. This all becomes 0 plus 1. It is 1, right? Okay. So now I come down to my graph. Sorry I have this. Am I going to really do 33 tick marks? If you think so, I'm going to laugh at you. Okay? Because I'm not. Negative 8, I'm going to do the 8 tick marks. And up here, I'll just say that's negative 833. As long as you tell me that's what it is, I'm cool with you just saying that's what it is. If it gets too high, does that make sense to you? Okay, and then here's 0, 1. That's my y-intercept. So I'm using symmetry. This point is at 0, 1. My head, if you think, is at negative 833. What's this other point over here? I'm 8 units away from that point, correct? Does everybody see that? So if I go another 8 this way, where am I at? Negative 16. 1, 2, 3, 4, 5, 6, 7, 8. I'll also be at 1, but that's at negative 16, comma 1. Yes, no? Does that make sense? Using symmetry? Go through your points, though. Okay, I have something to let you know. Notice this graph is a max graph, right? The previous graph was a low point. Hold on, don't put them away. I got one more thing to put you on there. Now, what was the a value of this equation? Negative a half, right? What was the a value in this equation? 1. If your a value is positive, write this down. If your a value is positive, you're going to have a min graph, or a low point. If your a value is negative, you're going to have a maximum graph. And the reason is because you take something that's x squared, it'll always be going up. But as soon as it's negative x squared, it floats you down. Yes? Yep. If your a value is positive, you're going to have a minimum graph. If your a value is negative, you will have a maximum graph. So when you're graphing, it's good to check your work and realistically think, what should it be, right? Does everybody understand that? So with that being said, really quickly, watch what I could do there as well. If I write this, y equals 2x squared plus 10x minus 3. Just really quick. I could do the increasing and decreasing of this graph just by finding the vertex. Because is this graph going to be going up or is it going to be going down? Is it going to have a min graph or a max graph? Min, because my a value is positive. So I already know it looks basically like that. So what do I have to do? I have to go ahead and find my vertex, and then that can tell me where I'm increasing and decreasing. And how did we find our vertex? Negative b over 2a. That tells you the x value, and then you can go ahead and find the y value, right? So do I even need to graph that? I can just do a rough sketch because I know what is which. By meaning in positive a value is a minimum, negative a value is a maximum. Okay?